So picking up where we left off, we have a bit pattern here. This is a 2 byte bit pattern. We'll again in the previous video we sort of broke it up like this. So we'll go ahead and go back and set it up that way. So see if we can make this any clearer. Byte is 8 bits. We will just 2 byte pattern. We'll do a bit of that. A little fancy notepad formatting. And a byte has a bit patterns, 2 byte. All right, so that's essentially, again, as we talked about in the previous video, this is really just 16 bits smashed together with absolutely no separation or anything like that. As far as the computer is concerned, the processor and all that, it doesn't need to separate it in any way. It's just bits. Um, so max value is that. All right, so going back to what we were talking about in the unsigned tutorial or tutorials, because we went over it a couple times. Let's um, imagine that we're looking for, as we said, um, that all integers are 4 bytes. So what a 4 byte integer is going to be is this, and whenever depending on the size of the value, we're going to say this is the first bit, this one on the top left, and then on the bottom right, it's the last bit. Now, there's some subtlety and certainly some craziness sort of is involved in this. You can look it up depending on how technical you want to get. There's the least significant bit, there's the most significant bit, and it's sort of architecture and platform dependent. And we're not going to delve into any of that stuff. That's sort of what we're talking about right now with the bits and the bytes and stuff like that. We're glazing over it to some detail, or to some extent, and this is as low as we're going to talk about in this series, unless I get a ton of requests or something. I'll go into it further. But this basically is as low as we're going to go, and this is pretty damn low. I mean, you're talking about bit patterns and bytes and stuff like that. I mean, you're sitting right on top of the processor and how it interprets data and how data is represented um, in memory. And so just let's recap on this a little bit. There's bit patterns, memory locations have values, and values are bit patterns. So the bit pattern of a value never changes. So let's, whether it's -1 or or some other random value, let's just say that this is a bit pattern. It whether it's signed or unsigned, the processor, and the value in memory is never going to change unless something acts on it or forces it to change, or using cheat engine we poke a value in there or whatnot. But this bit pattern right here, I'm going to cut it and then I'm going to paste it back. Is whether it's signed or unsigned, this value is never going to change. It is just that's the value of the memory, and what is going to change is how the application interprets this bit pattern. So if it's unsigned, it's going to just take these bits and it's going to convert it into a decimal representation. Well, maybe I'll get into binary to decimal conversion. We're going to have to at some point, because when you start doing scripts and things like that, you wind up converting between hex and decimal, and some explanation of the numbering systems and the radixes and stuff like that. We'll dive into that. But anyway, this bit pattern never changes, and if it's unsigned, it takes these 8 bits, it converts it straight into decimal, and that's it. And that's the value you get. Now, if it's we'll do get rid of that. We'll paste it down there. So unsigned, I have no idea what that is in unsigned decimal. I'm not that fancy, but for signed, what you're going to get is entirely different, because what it's going to do is it's going to look at this first bit right here, and it's going to say, is it a 1? Well, then this, I don't know if I have it backwards, but just for explanation's sake, if it's a 1, then this number is negative. So how can we sort of express that a little bit? Let's say if for for a signed integer, if the first bit is 1, the number is negative. If it's not, then the number is positive. And that's it. And that's, you know, again, there's subtlety here, and we're glazing over it, and I'm typing it in Notepad, so it's not that fancy, but essentially this is how positive and negative numbers work in pretty much every platform, and certainly this is how it works in x86, in a general sense, which is what most people use, and what Cheat Engine operates on, and so using this or building on this, we know that it's the difference between this and this is only in how the application is interpreting that value. The bit pattern never changes. So with that knowledge, we can go back up here and say, oh, we're searching for a 4-byte, value, or a 4-byte integer, and whatever, just random things that are 1 or 0, whatever. This is equal. This bit pattern is equal to some decimal value, and I don't know, it's probably like 3 billion or something like that. And when you go to Cheat Engine and you type in a value right here, as we were doing before, I forget if I've restarted the Shadowrun. I'm not even running Shadowrun, so I can't really search right now. But say you type I don't know, 1, 2, 3. We had 1, 2, 3. I don't fuck it. 3, 2, 1. So say you type 3, 2, 1 into that text box. What Cheat Engine does, takes that value and it converts it into whatever the value type is down here. So it will make it 4 bytes. And so what it's going to do is it's going to take 3, 2, 1 and it's going to convert it into a 4-byte pattern, or a 4-byte bit pattern, if you will. And then it's going to search memory in 4-byte chunks for that bit pattern. If you did 2 bytes, what Cheat Engine is going to do is it's just going to chop off those first 2 bytes and it's going to search for that value. I forget what it was. I think it was. Let's see if we can go back here a little bit. Nope, can't. All right, so yeah, when it's 2 bytes, it's just that's it. It's going to take 8 or 16 bits. It's going to take that value. It's going to put it into a bit pattern, and then it's going to search memory for that. All right. So we've gone over that, signed bits, unsigned. Let's see if we can cover anything else in this video here real quick. Max values, data types. All right, so let's go over that a little bit. I'm not sure how much time I have left in this video, but say max value of data types. So say go to Cheat Engine, telling it we want to search for byte. Now, and let's say 3, 2, 1 is what we want to search for. Now, this is a contrived example, but this is the bit pattern that Cheat Engine is going to search for. Now, before we can talk about how it before we think about how it converts the value into a bit pattern, let's ask ourselves, how do we express 0 in a bit pattern? Well, it's pretty simple. As a bit pattern question, it's pretty easy. Every bit is 0. If any one of these bits, any bit in this bit pattern was not 0, then the value as interpreted by any sane program would not be 0. So if you make that a 1, well, now it's not 0 anymore. This is some decimal value that's greater than 0. Even if you make the last bit 0, well, this is now equal to 1. If you can read Wikipedia how to convert it, but now that's 2. So on and so forth. And then you change that to 1. Now that's as a decimal value is 3. So on and so forth. I'm not going to go into the conversions or whatnot, but what I'm driving at here is if we make every one of these, we're searching for just a 1-byte pattern, and there's 8 bits in a byte. So if we max out every bit and we go to 111, you can't stuff any more information in here unless you expand the actual size of the data type. So I'm searching for 1 byte, and what's the max value that you can stuff into a byte? As it turns out, it's 256 as an unsigned byte. So unsigned byte max value is 256. Is it 256 or is it 255? It's 255 because you have to count 0. All right, so it's 255. So a signed byte max value is Well, as we talked about earlier, with assigned byte or assigned anything, the first bit is automatically for signed. First byte bit is the signed bit, so it cuts the values in half. So we have 7 bits left. There is, again, there is a bit over here, for the 8th bit, but it's not counted against the, what it converts to in decimal. So you just have 7 bits, and if you max out 7 bits and you feed that, convert it to decimal from binary to decimal, then what you get is something along. I want to say it's 126, and I believe the max negative value is 127, or I don't know. This is incredibly esoteric stuff off the top of my head. I'm not. I might be off by one, uh, but whatever the case may be, this is why in in incredibly pedantic detail, this is why signed values um, or signed data types always hold half as much as the unsigned. And there's some slight. There's a little bit more to it than this, but I'm not going to go any deeper than this. This again, you don't have to know all this stuff, but when you get into writing assembler scripts and stuff with Cheat Engine, I mean, this is the kind of stuff that is going to is it guaranteed to give you bugs? No, but if the application, it's say Shadowrun, which is what we're using for the examples. Let's say Shadowrun is in the language, in the programming, the source code, if you will, that Shadowrun was written in, say that it declares a variable as signed. So just somewhere in Shadowrun's code, it says, okay, there's a signed integer. We're just making up this language here, but there's a signed integer, and they'll have some label for it. So we'll call it player um, karma, and it equals some value. Who gives crap what the value is? But it assigns. It doesn't even matter what the value is, frankly. It just what it's doing is it's declaring that it will read this as when it interprets this bit pattern of whatever the value of player karma is, the variable player karma. It's going to interpret it as signed. So why are we just talking out of our ass here, or what are we doing? No, this is important, as I've been attempting to explain, and perhaps maybe not doing a good job, but when it takes the byte pattern, or I'm sorry, the bit pattern, and it reads it into the application Shadowrun reads it, it is looking for the signed bit. So if you, using Cheat Engine, if you find the value for your karma, like we did, and then you start cramming values into it that are larger than this data type, then the application is interpreting this bit pattern as, then you're going to crash the program or get ridiculous results that make no sense to you. So just let's back up for a second and let me pull this up real quick and see how long we've been on. See, does it even give me a time? Current file size, actual time elapsed 812 seconds. I have no idea what's that going to be. I want to say it's like 5 minutes. So 60 seconds times, I don't know, 10. We're getting close. All right, well, I'll pick this up in another video.